Good morning, sir. I am Harbhajan Mishra from SGSITS IT branch second year section A. This video is about linked list. We can say that linked list is a type of data structure which is dynamic in nature. Here we can see that there is a node in which there is a data or value and a pointer variable which is pointing to the address of next node. Similarly, next node has a value and a pointer variable which is pointing to the address of next node and so on. Just like if there is a last node, its pointer variable will always be pointing to null. Since it is dynamic in nature, we can grow or shrink its size according to our need during the execution of program. We can make it as 0 as long as we required. It does not require any kind of contiguous memory allocation. That's why it saves a lot of memory space. Now, why we use linked list over array? Firstly, we know that array requires contiguous memory allocation while linked list does not require it. In array, we can define array only if we have contiguous memory, but in linked list, in any memory available, we can make linked list just by storing their address using pointer variable inside the node. So in array, the inserting and deleting of an element is quite hectic as compared to linked list. Also, there is a concern for memory. Now we will see how can we do insertion and deletion in linked list. If we have the linked list of like this and we have to insert a value of x in between a and b, we can just simply change the value of pointer variable inside the node and insert x in between a and b. Now, if we will say that x node is temp and current node is a, we just have to current of next pointing to address of x and current of x pointing to address of v. In this way, we can insert x. This is the pseudocode. We have a structure and its object node. We are just temp of next is equal to current of next and current of next is equal to temp. But if we will use array, it is very difficult for us to shift b and c further and insert x in between. Now we will see deletion. If we have to delete b from this linked list, we just have to play from reference variable inside the node. We will just put current of next to the address of c. But if there was array, it is very difficult for us to delete b and then shift c behind and delete some memory. This is the pseudocode for deletion, in which we have a structure, its object node, and then we will just doing that. In temp pointer, we are storing current of next address, and current of next we were pointing to the temp of next. In this way, we can delete some any element from a linked list. Now, in insertion, we just have to set the pointers and we can go with the process. Now we can see the type of linked list. There are three type of linked list, in which first is the singly linked list, which can be also called as simply linear linked list. Here we can see the example that one is node is pointing to other and other to other and so on. No complexity. Now second is circular linked list, which is just as same as singly linked list, but the last element pointer is not pointing to null, it is pointing again to the head of the linked list. Now another is doubly linked list, in which we have in which we will have two pointer reference pointer variables. In one of the variable, we will store the address of next node, and in other we will store the address of previous node. And in this way, our doubly linked list will be go on, and here we will have head and tail. Now some operation which can we do on linked list are creating a list, traversing through the list, insertion, deletion, and concatenating two lists into one. Thank you. Okay. Also we can see that how can we create a linked list. So in which first we will use dynamic memory allocation. We will make a node and we will assign it to head. In this node we will have only two things. Is the one is this value, and other is a pointer variable, just like this, in which first we have k and n. This is our node. Yes, so this is our node in which we have pointer and value. We are assigning this pointer the address of head, and we are assigning the last nodes next to the null. Now how can we traverse in a list? First we will keep the record of first element of linked list as head, and then we will go through head of next, a temporary node, and temp of next, temp of next, temp of next. Thank you.